Very good morning, all of you. Welcome to refrigeration and air conditioning class. In first unit, I left only two topics to be discussed. They are in aircraft refrigeration system case. Already in last class, I discussed about simple aircraft refrigeration system, on which some problems we covered for examination point of view. Now only two topics are left. They are aircraft refrigeration system with evaporative cooling and bootstrap air refrigeration system. So in this class, I discussed these two systems. Then we'll finish this first unit. Okay. Now, now let us move to simple air refrigeration system with evaporative cooling. Last class I discussed about without evaporative cooling. Now I am talking about with evaporative cooling. See all of you this diagram. The only difference between previous diagram to this one is that I have added one evaporator in between air cooler and turbine. The only difference is that in between air cooler and turbine, I have added one heat exchanger called evaporator. That is the difference, but working wise same. See all of you, atmospheric air first of all enters into diffuser, in which ramming process takes place. So due to this ramming process, the air atmospheric pressure reaches and increases to certain level. So pressure value increases. So after this pressure, you will be having stagnation temperature after ramming process. So we reach, see all of you may cursor, we reach here. Then after diffuser, the compressed air due to diffuser, due to ramming process, that will be entered main compressor, where one more time pressurization takes place. So with high pressure, the air reaches to heat exchanger or air cooler. So here, this is heat exchanger. Over the heat exchanger, we supply some amount of ram air. Inside the tube, we have high pressure air, which is coming from compressor. So high pressure air having high temperature, ram air is having low temperature compared to this compressed air. So due to this temperature differences, heat transfer from compressed air to ram air. Compressed air to ram air, some amount of heat rejection takes place in cooler. So after that, in previous diagram from cooler, I directly move to turbine. But here in this system, before going to turbine, the air which is coming from cooler is moved to evaporator. So this is evaporator. So inside the evaporator, see this is evaporator tube through which the air coming from cooler is passing. But over the tubes, we supply one medium like alcohol, ammonium or water, whatever it may be. So due to that heat transfer, this medium will be evaporated. So the name already tells you evaporator. So it evaporates one fluid, that may be water or ammonia or alcohol, whatever it may be, at low pressures. So you have to see saturation temperature at required pressure. So at sufficient pressure, we go for evaporation. So finally, that will be supplied to another application. So after heat evaporator, the air coming from evaporator is entered turbine. So once again, expansion process takes place here. So here expansion takes place. Low pressure or cabin pressure, you will be reaching cabin pressure, and low temperature will be obtained. With low temperature and cabin pressure, the air will be supplied to cabin, where heat will be added from occupants or equipment. Then air temperature increases. So like that, this working will be going on. So this is simple air refrigeration system with evaporative cooling. The only difference is that evaporator I have added, in which evaporation takes place by using some amount of medium. So that is the thing. And next one is that bootstrap air refrigeration system. So here there is a chance for getting problem in examination. That's why I have given sections, and I provide a TS diagram also for this. So using the diagram, you can do problems. Simple problem, what we discussed in simple air refrigeration system case, and same type will do problem. So here see all of you without evaporative cooling case, but bootstrap air refrigeration system means the air which is coming from main compressor is one more time will be pressurized before entering into turbine. So uh, that is the bootstrap refrigeration system. See all of you, I'll tell you working, then you can understand. Atmospheric air first of all enters the diffuser, where ramming process takes place, and pressure value increases. So with increased pressure, we have reached section 2 now. With increased pressure, from here air moves to compressor. This is called main compressor or primary compressor. So where one more time pressurization takes place. With high pressure and high temperature from main compressor, the air is moved to cooler. See all of you, this is cooler. See all of you, my cursor, this is cooler, where heat is rejected to ram air. Now temperature is decreased while coming from cooler. Temperature of air is decreased. Now in previous diagram, in without evaporating case, in simple air refrigeration system, after cooler the air directly moves to turbine. But here see what is happening. Before entering into turbine, first of all the air coming from cooler is entered one compressor, one more compressor called secondary compressor. One more time pressurization takes place. So with high pressure, once again this is moved to one more cooler. So two coolers I have used, two coolers for two compressors. So one more time heat is rejected. So with low heat, with heat rejection and with low temperature, this air is moved to turbine. Now it is moving to turbine. After that expansion process takes place, we reach cabin pressure and low temperature after expansion process. So with very low temperature and cabin pressure, the air is moved to cabin where heat is added from occupants or equipment. So this is the working of bootstrap air refrigeration system without evaporative cooling. So here I have used two compressors, two coolers. Uh, First compressor is called as main compressor and second one is secondary compressor. After every compressor we provide one cooler by which heat is rejection. So this is bootstrap air refrigeration system. So the TS diagram for bootstrap air refrigeration system, which is important for problem case. So we have to see number of processes here. Ramming process, first one, from atmospheric air to diffuser. Here compression takes place called isentropic compression 1-2. Practical case 1-2 dash adiabatic. 2 dash to 3 isentropic compression in main compressor. 2 dash to 3 dash adiabatic compression. After main compressor, air is moved to this first cooler, first air cooler 3 dash to 4. First cooler where heat is rejection, temperature is dropped. Then air will be moved to secondary compressor where in, when you go for theoretical compression isentropic 4 to 5. In actual case 4 to 5 dash adiabatic compression. Then again that air will be moved to secondary cooler, second cooler where heat is rejection 5 dash to 6, temperature is dropped. Then air moves to a turbine, expander, isentropic expansion in theoretical way, adiabatic expansion in practical way. 6 to 7 is isentropic, 6 to 7 dash is adiabatic. Then it moves to this one, cabin. Cabin means temperature rises due to occupants or equipment 7 dash to 8 practical. So this is TS diagram for bootstrap air refrigeration system. If you get a problem on this, using these processes, we have to find out unknown temperatures first of all. When we have total temperatures in the cycle, then we'll move into objectives. Here we have do compressor works. So power required to drive the system means um, uh, total compressor work you need to take means compressor work for main compressor, compressor work for second compressor. So equations wise, if you see MCP T3 dash minus T2 dash for main compressor, that is compressor work value, MCP T3 dash minus T2 dash, then plus MCP T5 dash minus T4 secondary compressor work. So the combination of these two works will give total compressor work. This is called power required to drive the compressor. Refrigerating effect is here MCP T8 minus T7 dash. T8 minus T7 dash refrigerating effect. So using these two values, we can determine COP of the system. Refrigerating effect by work input to drive the compressor. So you will be getting COP, that ratio. So you need to calculate first of all temperatures, then only you can determine the COP and remaining objectives. Please do concentrate on this diagram. Thank you all of you. That's all for today. Next class I'll move to vapor compression refrigeration system unit 2. Thank you.